Hi, grade 9. So this is our last lesson on chemistry before your quiz this afternoon. So we're going to be focusing on collecting gases and testing for certain gases, because obviously that is something that gets produced a lot in a chemical reaction. So we need to know how to, one, collect it, and two, actually figure out what gas we have present. So you should have your notebook in front of you so you can write your notes, and the handout in front of you as well. Okay, so we'll do a quick science starter. So I want you to define a chemical characteristic, list 3 examples of physical characteristic, and determine the number of atoms of each element in that compound there. Okay, so we know that chemical characteristic basically has to do with how it combines with another element or compound. Physical characteristics, anything like color, taste, smell, boiling point, melting point, any of those. And then we have in this one 6 carbon, 1 hydrogen, and 6 oxygen. Okay, so like I said, we often perform tests to determine the presence or absence of certain gases. So for example, hydrogen, carbon dioxide, oxygen. In order to test for those gases, they first need to be collected. Okay, so in this lesson, we're going to focus on collecting the gases, and the other video is going to be testing the gases. Okay, so some gas collection methods that we use. So it depends on the density and the solubility of the gases in water. So density of the gas, so does it rise or does it sink? And solubility, does it dissolve or not in water? So the methods are the gas syringe method, downward delivery, upward delivery, and also over water. Okay, so for each of these pictures, I want you to think about which method is being shown. So is it the gas syringe, upward, downward, or over water? So I'll give you 30 seconds or so. You can pause the video to think about that. Okay, so the first one, you can see that the gas is moving upwards. That is upward collection. This one, you can see the syringe. So that is the gas syringe method. This one, there's a water trough. So that's the over water. And then the last one, it's going downwards. So that is the downward delivery. Okay, so the first one, we have the gas syringe method. So any gas can be collected using this method. So basically you have a reaction taking place in a sealed flask. It produces a gas which goes up into the gas syringe and causes the plunger to move out so you can collect the gas. Okay, upward delivery is used when the gas is less dense than air. So that basically means that the gas will rise and the air will sink. Okay, so the gas rises and takes place of the air in the jar. So again, the reaction is taking place in the flask. The gas produced goes up through a tube into the test tube, and then that pushes the air out and the gas collects in the top. Okay, so it cannot be used for gases that are more dense than air, because then the gas would just fall out the bottom. And so hydrogen gas, for example, can be collected using this method. Okay, and then we've got downward delivery. So this is used when the gas is more dense than air. Basically, the gas will sink downwards and the air will rise up. So the gas pushes the air out of the jar and replaces the air. Okay, so we have the reaction taking place. The gas produced moves through the tube into the test tube. Gas collects at the bottom and it pushes the air out. Okay, so carbon dioxide is an example of gas that can be collected this way. And again, it can be not used for gases that are more dense than air. Or sorry, less dense. I was right the first time. It's not reading my sentence properly. So it cannot be used for gases that are less dense than air, because that would make them rise. Okay, and then the last one is the over water method. So you can see this water trough here. Okay, so the gases can be collected over water as long as the gas is not soluble or is only slightly soluble in water. So that means it's not going to dissolve in water, or it's only going to dissolve a little bit. Okay, so hydrogen, carbon dioxide, and oxygen can be collected this way. So if the gas is soluble, then the method wouldn't work, because the gas would just dissolve into the water and you wouldn't be able to collect it. Okay, so again, we have the reaction taking place. The gas is produced, goes through the tube, and then it kind of bubbles up into this bigger beaker, and it pushes the water out, and then it fills it up in the inside. Okay, so a quick quiz just about those 4 methods. So true or false. Again, you can just do this in your head. So upward delivery method is used to collect gases which are more dense than air. Is that true or false? Okay, that should be false, because if they were more dense, that gas would just fall out. You wouldn't be able to collect it. Okay, water trough can be used if the gases are soluble in water. Is that true or false? Okay, that would also be false. It can only be used if they are not soluble or only slightly soluble. A gas syringe can be used for all types of gases. Is that true or false? Okay, so that is true. And then oxygen does not dissolve in water, so therefore it can be collected in a water trough with the over water method. Is that true or false? Okay, so that is true. Okay, and then there's a practice question here. So we have a couple application questions. So ammonia is a gas which is less dense than air, but is soluble in water. Which methods can be used to collect the gas, and explain why? You can also say which method you couldn't use. And then chlorine is more dense than air, not very soluble. Which methods could be used to collect the gas, and explain why? And again, you could also say methods that would not be used. So you can pause the video here and take a few minutes to answer those questions. Okay, so we got the answers just to the first one. So we're talking about ammonia, less dense, soluble in water. So we can always use the gas syringe because we know that all gases can be collected using this method. We can use upward delivery because it's less dense than air, but we cannot use downward delivery or over water because we know that it is soluble. Okay, so I'm not going to take up the second one. That's going to happen in your exit ticket. Okay, so you can watch the second half of this lesson, and then again, you can get ready for your chemistry quiz later this afternoon.